So in this problem, we're given cosine of theta is -½ and theta is lying in the second quadrant. Using this information, we need to find out the value of the remaining 5 trig function. So let's begin. So first, let's note down whatever has been provided to us. So here we have cosine of theta. So that's equals to -½ Now, since we have the value of cosine theta, we can obtain secant of theta. So since secant of theta is defined as the reciprocal of the cosine function, so reciprocal of -½ will be simply -2. Now we need to understand the sign. So here we have the coordinate, the Cartesian plane, which is divided into the 4 quadrants. So we have 1, 2, 3, and 4. The quadrants are defined in such a way that means in the first quadrant the angle theta lies between 0 and pi over 2. In the second quadrant, we have theta lying between pi over 2 and pi. In the third quadrant, we have theta lying between pi and 3 pi over 2. And finally, in the fourth quadrant, theta lies between 3 pi over 2 and 2 pi. Now, we'll use a mnemonic to remember the sign of the trig function. We have A, S, T, C. So A means all positive. All the 6 trigonometric functions are going to be positive in the first quadrant. Then in the second quadrant, we have S, which means the sine and the cosecant function. So these 2 functions are going to be positive, rest are going to be negative. In the third quadrant, we have tangent and cotangent. They are going to be positive, rest are going to be negative. And finally, in the fourth quadrant, we have C, which is the cosine. And we can also have secant functions. So these 2 functions are going to be positive and rest are negative. And since we are in the second quadrant, where only the sine and cosecant functions are positive, so that's why we have cosine function and secant function obtained in giving us a negative value. Now, we're going to use a fact. We know that 1 plus tangent squared theta, so that's a standard identity with a value secant squared theta. To find out the value of tangent squared theta, all we have to do is replace the value of secant squared theta with -2 whole squared. And solving this equation will help us obtain the value of tangent theta. So we have -2 whole squared minus 1, which will be equals to 4 minus 1 equals to 3. So this is the value of tangent squared theta. Taking the square root on both sides, we're going to get tangent theta equals to plus or minus square root of 3. Now, since we are in the second quadrant, the tangent function is negative, so we'll have to consider the negative value. So tangent of theta will be negative square root of 3. Now we have obtained the value of tangent theta, which means we can also obtain the value of cotangent of theta. So cotangent of theta, that's simply the reciprocal of the tangent function. So 1 over tangent theta, that means we have 1 over square root of 3 and with a negative sign. So this is the value of cotangent theta. Now, we know that the tangent function is also defined as the ratio of sine over cosine, which means sine theta can be easily obtained by multiplying tangent theta with cosine theta. So tangent theta, that has a value of, we have obtained tangent theta as negative square root of 3. And cosine of theta, that's given to us as -½ So that means sine theta has a value positive square root of 3. And it's positive because we are in the second quadrant where sine is positive. And since we have sine theta, we can immediately find out the value of cosecant theta, which is 1 over sine theta. And that means we are going to get 2 over square root of 3. So hence we have successfully obtained the value of all the remaining 5 trig functions whenever cosine theta is -½ and theta lies in the second quadrant.